Hello YouTube family. So welcome back to my YouTube channel. Today we are going to solve the day 5 problem, and I have already made videos tutorials on day 1 problem, day 2 problem, day 3 problem and day 4 problem of 2024. So if you haven't subscribed my YouTube channel yet, then please subscribe it. And now without any delay, let's get started with day 5 problem. So this is the problem, longest increasing subsequence. So we have given an integer array nums and we have to return the length of the longest strictly increasing subsequence. Okay, so let's try to understand this with an example. So here this is the nums array given to us, and we have to find the longest increasing subsequence. Okay, so let me copy this input and output and paste it here. Okay, so here to solve this question, we let's create one tails array. Okay, so in this array we are going to store the longest increasing subsequence elements. Okay, so for that purpose, first let's say we go to this 10. Okay, initially when we go to this 10, so yes, since tail is empty, so let's insert this 10 first here. Okay, after that we go to this 9 and see, check here, this 9 is less than 10. If this condition is true, if this 9 is less than 10, then just replace this 10 with 9. Okay, after that go to next element in nums. So next element is 2. So this 2 is less than 9, true. If this is true, then just replace our tails array with first index is 2. Now after that go to next element 5. So this 5 is greater than this 2, tails last index. Yes, it is true. So in that case we are going to just add this 5 in the next index. So we are going to append our array. Okay, in the next index we are going to add this 5. After that we are going to check the next element in nums array, which is 3. So since 3 is less than 5, then we are just going to replace this 5 with 3. Okay, and then we will check 7. So 7 is greater than 3. Okay, so if this element is greater than 3, then we will just add this element in the our new tails array. Okay, so we have added 7. After that go to the next element. So next element is 101. So 101 is greater than 7. Yes, so if it is greater than 7, then we are going to add it in the tails. Okay, so I have added 101. After that go to the next element. Next element is 18. 18 is smaller than 101, so we are just going to replace this 101 with 18. Okay, so this is the approach that we are going to use to solve this problem. So total size is 4. So this is going to be the output. Okay, this is the output for this problem. So now I will write the code of this problem and you will get more better idea with this solution. Okay, so first, as I told you, first we are going to create an array to store the tails of the potential subsequences. So just declare one array, initialize one array, int tails is equal to new int and give the length as nums.length. Okay, and after that just initialize size to 0. Initialize size to 0. Okay, so let's write int size is equal to 0. In the end of this tutorial video, I am also going to explain this code with a step-by-step explanation of one example. Okay, so just watch till end and you will get more better idea. Okay, so now I have declared one initialize the size to 0, and after that we are just going to iterate through each element in the input array. So for that just write one for loop for int x of this nums. Okay, so first we are going to pick first x. Okay, so on, so it's go on, and then just initialize the binary search point. So we are going to use binary search tree algorithm here. So first initialize the binary search pointers. Int I is equal to 0 and give value of j as size. Okay, and now after that we are going to perform the binary search. We are going to perform binary search. Okay, so for binary search, write while I is not equal to j. Okay, so in this we are going to write performing our binary search, and initially this tails is empty, so initially I value is 0 and j is equal to size, so size is also 0. So when initially that the tails is empty, so for that we are just going to update the tails array at the found position with the value of x. So here write tails of I is equal to x, and if x was inserted at the end of tail array, so as I told you, then we have to just increment the size. Okay, so if I is equal to size, then we are just going to increment the size. That's it. And in this we are going to perform our binary search. So for binary search, how to perform. So first we are going to create one variable int m, and here we are going to pass both I plus j, and we are going to divide it by 2, and then we are going to update the pointers based on the comparison. So first let's say if tails of m, if the value of this tails of m is less than x. Okay, if it is less than x, then we are just going to increment I is equal to m plus 1. Okay, that's it. And else and here in the else part we are just going to update j as m. Okay, so let me, okay, we didn't give the return, so in the end just pass the return statement here. Okay, just add return size. So let me run this code. Okay, cannot find the symbol. I. Nice. And is there any other issue with the code? So our test cases haven't passed. So let me try to submit it. So our solution is accepted, and the runtime is just 2 milliseconds. So now let me explain this code to you guys, how this will work. Format code. Let me copy it here. Okay, and this is the link to my Medium blog. So here I have already mentioned all the steps that we are performing for let's say this example. So let me copy it as well. I'm going to paste this Medium blog link in the description of my YouTube channel, so you can check it out. Okay, so here as you see, first we are creating initializing the array here. So initially our tail array is like this, and we have initialized the size as 0. So here size is equal to 0 initially. Okay, so in this example first this 10 comes. Okay, so when this 10 comes, then at that time our I is equal to 0. Okay, so here you see I is equal to 0 and j is also equal to size, so size was 0. Okay, so I is equal to 0, j is equal to 0. Then we will check this condition while loop while I is not equal to j. So this is not true. Okay, as of now this is not true, so we are not going to perform this binary search as this moment. Okay, so now we are not going to perform this, so we just update this tail of 0 here. You see this tails of 0 is equal to tails here 10. Okay, this tails of this m, tails of I, tails of 0 is equal to x, tails of 0 is equal to x, so x is 10. That is why tail is equal to 10 here. Tails is equal to 10. So first we just tails of 0. Okay, this is tails of 0 is equal to 10. Okay, just read it like this, tails is equal to 10. Okay, and the size is 1. Then in the next iteration we pass 9, and now when we pass 9, so I is 0 and j is equal to 1. Why j is equal to 1? Because here I have mentioned that if I is equal to size, then we will increment the value of size by plus plus. Okay, so when I plus plus size, then our j will become 1. So now I is not equal to j, this condition is true. Then we go to this m, so m is equal to I 0, j 1, 1 divided by 2 is equal to 0, so m is 0, j is equal to 1. So in this case we are going to check this tails of m. So tails of m is equal to 0, so tails of 0 is 10, is less than x, new value of x, that is 9. So if 10 is less than 9, false. So in this case we are just going to update this j is equal to m. Okay, so when j is equal to m, so the j becomes 0 here, j becomes 0. Okay, now our tails become tails of 0, I 0, 0 is equal to x, x is equal to 9 this time, so tails become 9 here. Okay, and now again you are going to compare I is equal to size, so this is not true, so size will not be increment here, so size remains same. Okay, size remains same, only the value is replaced by 9. Okay, so this is what going to happen. So these are all the steps. Okay, so you can refer to this medium blog, and in this code I have added all the comments that you need to know. Okay, so I hope that you guys are able to understand today's tutorial. So please like, share and subscribe my YouTube channel, and keep coding and keep practicing daily. Thank you.